In today's topic, we are going to look at polar and non-polar covalently bonded molecules. In order to determine if a molecule is polar or non-polar, let's look back at a definition of electronegativity, where electronegativity is the ability of an atom to attract the shared pair of electrons in a covalent bond. So this electronegativity looks at how strongly a nonmetal atom will attract the shared pairs of electrons in a covalent bond to itself. So we are really looking at individual bonds in a molecule to determine if it is a polar bond or a non-polar bond. Then we will be able to determine if the molecule as a whole is polar or non-polar. Before we continue, let's also take note of the fact that fluorine is the most electronegative element found in the periodic table. And as such, elements such as oxygen and nitrogen are also highly electronegative. I will also take the opportunity, before we go into detail about differentiating a polar covalent bond from a non-polar covalent bond, that the word polar signifies the presence of partial charges and non-polar means no charges or no partial charges. The reason why I'm using the term partial charges is that if full charges were to exist in our molecule, that would mean it would be ionic. So there are no full charges in covalently bonded molecules. There may be the presence of partial charges, and that is if a bond is polar. Now, let us look at our definition of a polar covalent bond, where it is said that a polar covalent bond exists between two covalently bonded nonmetal atoms, where the nonmetal atoms are of different electronegativities, and because they have different electronegativities, their ability to attract that shared pair of electrons would differ, meaning that the attraction of the shared pairs of electrons is unequal, such that partial charges develop. You are told the less electronegative atom develops a partial positive charge, and the more electronegative atom develops a partial negative charge. Now, I want to look at an example. So let's say we have water, and I'm just going to draw the atoms that I will find in a water molecule. And of course, there will be some sort of bonding pairs between our oxygen and hydrogen atom. Think of the sharing of the electron pairs between the nonmetal atoms as a tug of war. So, in this instance, we would say that the more electronegative atom, having the ability to attract shared pair of electrons towards itself, will pull the shared pair of electrons towards itself. Right? Like in tug of war, the electrons will shift towards our more electronegative atom, and as such, it will develop a partial negative charge. So that's our more electronegative atom, which is oxygen. And the less electronegative atom, which is hydrogen, will develop a partial positive charge. So let us insert our partial charges into our molecule. So we have a delta negative, meaning a partial negative charge, and a delta positive for a partial positive charge. We have another hydrogen atom here, so this is also going to develop a partial positive charge. So overall, our molecule will be polar. Let's look at one more example, which is HCl. Chlorine being more electronegative than hydrogen means that because we have different atoms in our molecule, they will have different electronegativities and an unequal sharing of the shared pairs. Chlorine being more electronegative, it will develop a partial negative charge. Hydrogen being less electronegative, it develops a partial positive charge. Overall, the entire molecule is polar. Ammonia is also polar as well, and here we have ethanol, which is polar. Fun fact, ethanol is considered to be a solvent as well as water, but we say that water is what we call our universal polar solvent. And that's looking at polar covalent bonds. Let's look at nonpolar covalent bonds. It is said that nonpolar covalent bonds exist between two covalently bonded nonmetal atoms where the same nonmetal atoms will have the same electronegativity such that the attraction of the shared pair of electrons is equal for both nonmetal atoms, and resulting from this is that no partial charges can form. So for example, if we have two oxygen atoms, just like in tug of war, if the same strength is being applied on the attraction of the shared pair of electrons, and the shared pair of electrons do not lie closer to either oxygen atom, we say that there are no partial charges and the bond itself is a nonpolar covalent bond. And this would also mean that the molecule is nonpolar. The same applies for hydrogen and nitrogen, all three of which are diatomic molecules. They will all be nonpolar, where we have methane. If we look to our periodic table, we will see that carbon is somewhere in the middle. And while it does have a slight amount of electronegativity, and as a result of that, these bonds should be slightly polar, what results in our molecule is that due to the presence of these four slightly polar covalent bonds, any polarity in the molecule cancels due to the symmetry of the molecule, meaning that overall the molecule becomes non-polar. So you are to note here that methane is a non-polar molecule, as well as CCl4, which is called tetrachloromethane. And tetrachloromethane is regarded as a non-polar solvent. So let's recap. We have polar bonds and non-polar bonds. If there are only non-polar bonds in a molecule, it can be overall non-polar, or it will be. And then there are a few exceptions, which I've mentioned here: methane, tetrachloromethane, where overall the molecule is non-polar. And one worth mentioning is the CCl4, which is a non-polar solvent. Let us end off this lesson by mentioning that the intramolecular bonding that we find in covalently bonded substances, they would all be strong covalent bonding, whether the molecules are polar or non-polar. The intermolecular bonding in both these polar and non-polar substances are weak forces of attraction, and the weak force of attraction may be hydrogen bonding, or it may be what we call van der Waals forces of attraction. In the next topic, we're going to look at how do we know what type of weak force of attraction, which is our intermolecular force, do we find in polar or non-polar substances. Just as a hint, in our polar substances, we are going to find hydrogen bonding, And in our nonpolar substances, we will find van der Waals forces of attraction. So in our next lesson, we'll go into more detail about these two weak intermolecular forces of attraction.